Okay, in this video we're going to be talking about similar shapes. So if anyone hasn't ever done it before, I've written a little description of what they are. So similar shapes are when you've got two shapes that are the same, but one is bigger than the other, so an enlargement of the other. It's slightly different to congruent. So if you had congruent shapes, that means that they're identical in every single way, including the size. This is similar to that, but rather than them being exactly the same length, for example, they can be an enlargement of the other, okay, but the angles do remain the same. That's really key that you remember that. Okay, so it's just the lengths or the heights of things that will change. The actual angles within the shape will stay the same. Okay, so we're going to start with the easiest questions first. So these are just finding the missing lengths. So we're going to start with EG1A. So we're given two rectangles again. One is just bigger than the other. We're given two lengths on this one and only one on this one because we need to find the other. Okay, so what we do is we compare the two sides that are the same that both have values. So we know that this one is 3 and we know this one is 12, and they're the same side on the shapes. Okay, so they're both the right hand side. Okay, so what we need to think is, what do we have to multiply 3 by to get to 12? So essentially you're finding the scale factor. So what we would do, we would times by 4, because 3 times 4 would give us 12. Okay, so I'm going to write down here, scale factor is 4. Okay, you could have done it the opposite way, so you could have done 12 divided by 3 and then seen obviously what that is, which is 4. So it depends on what method you want to use, but it doesn't really matter. Okay, so because we've times 3 by 4 to get 12, that means to find out what x is, we must have to do the same thing because we know that they're similar. So 5 times 4 would give us 20. So x is 5 times 4, which is 20 centimetres. Okay, so that's the answer to the missing side. Okay, so this bit's fairly nice, to be fair. So again, we look at the two shapes, we see that both the bases have the numbers. So this is 2 and this is 6. So the other way you could have done it was we do the bottom shape or the bigger shape divided by the smaller one, or vice versa. It doesn't really make a difference. I'm going to do this one to this one. So 6 divided by 2, which is 3. So the scale factor is 3. Okay, which just means that B is getting 3 times bigger than A. Now we know that the bigger shape is 15, so to go backwards, so go back to the smaller shape, we would have to divide by whatever the scale factor is, so divide by 3. So Y is going to be 15 divided by 3, which is 5 centimetres. Okay, so it's just a bit of logic. Obviously, if you're going from this one to this one and the scale factor is 4, because you're going from the first shape to the second, okay, which for both of these cases you're going from the smallest one to the biggest one, you would multiply by the scale factor. Okay, but because this one you're going from the second shape to the first one, you're doing the reverse of what we'd normally do, or what we did to get from 2 to 6, that's why you need to divide. Okay, so they're the basic questions that you could get. I have done a wordy one, because I have seen a couple of these sorts of questions before. So they say that pound notes are similar. The sizes of the notes are below. So this is the size of a £5, £10, and they've got the lengths of them in millimetres here. Are they similar? Now the way to do it is we need to see what the scale factor is to get from here to here, and the scale factor to get from there to there. Okay, if they are the same, then we know that they're similar. If they're different, then they're not similar, because it means that the one side is getting bigger quicker than the other. Okay, so we're going to start with the bottom numbers. So to get from the £10 to the, the £5, what doesn't really make a difference, £5 to the £10. Okay, I'm going to do this amount, the £10 one, divided by the £5 length. So I'm going to do 150 divided by 125. Now make sure you're doing the same side, so these are both the bases of the notes. Okay, so don't do this one and the side, it won't work obviously because they're the two sides that aren't the same. And then you can just use a calculator. These ones are quite tricky. If you wanted to simplify it like a fraction, then you could. So that's 1.2. Okay, so the scale factor is 1.2. Okay, and then we'll do the same thing but for the other sides. So again, I'm going to do the height of the £10 divided by the height of the £5. So 78 divided by 65. Again, I get 1.2. Okay, so now because the scale factors are the same, they are similar. Okay, if I got, for example, if I got 1.3 there instead of 1.2, because the scale factors are different, it means that they're not the same because the heights will be getting bigger quicker than the bases. Okay, so that's how you would do the scale factor bit. Okay.